Okay. Okay, greeting everyone. So today I'm going to explain my um, code for the machine vision exam. My name is Andrew Jonathan Siahaan. I'm from Mechatronics C class, morning class from 5th semester. This program implements a complete image classification, including data processing, HOG feature extraction, and FCM classification. I'm evaluating using both key fold and LOOCV. First here, but wait, I'm gonna explain the HOG is for extracts visual features, shape, and age from each character image, and then SVM classifies the character based on the HOG features, and then the LOOCV is the final, the for evaluates how well the SVM model performs. And then in this case, we are going to um, processing the handwriting. For the first, we import the libraries and setup here, such as NumPy, Pandas, SK image feature, and sklearn. I use SVC, leave one out, and cross-file predict for machine learning, cross-validation, and evaluation. Then I add TKDM as for progress bar to monitor how long the long of the process. And then the matplotlib and the seaborn for visualize the results, such as the confusion matrix. For the configuration path here, data, the main configuration here, data dir points to MNIST dataset in the CSV format. Then output dir here for stores all output files like logs and confusion matrices. And then samples per class, which is 500 samples here to ensure every letter from A to Z has an equal number of examples. And then I also add control here to run tuning mode to check the parameter tuning, and then the run LOOCV final for running the final evaluation using leave one out cross validation or LOOCV. Here the logging and visualization function. Right log here, function prints message on the screens and save them to the into the log file. And then the plot correlation matrix. The function visualize the classification performance. It uses seaborn heat map here to show where prediction match or differ from actual label. And then here the data processing for loading and sampling. This function handles the data processing stage. The dataset is loaded from CSV format, where the first column is the label and the rest are pixel values. All pixel values are normalized from 0 until 255 to 101 to make them consistent for training. The loop selects 500 samples per class, um, ensuring that each letter from A to Z is equally represented. And then all sample data and labels are stuck into arrays X and Y. And then here the HOG features. This part is the feature extraction stage. Each 28 times 28 image is reshaped and processed using HOG or a histogram of oriented gradients. Here the key parameters, the orientation is 9, the number of it's the number of gradients directions, pixel per cells 6,6 is the each 6 times 6 region is one in it is in one cell. Then cell per blocks 2,2, it's the group of cells for normalization. And now here is the key fold evaluations. Before running the LOCP, I perform a 5-fold cross-validation as a quick test. Includes a standard scaler here to normalize the HOG features and SPM classifier with C 1.0. Controlling regulation. The kernel is linear, which works well with high-dimensional HOG data. And then evaluation method here. In LOCP, each sample is tested one by one. For every iterations, one image is used as the test set while all others are used for training. This ensures very accurate evaluation since every sample contributes to testing phase. However, it's extremely time consuming for a large dataset. For this code, uh, for 13 data, it's taking almost 10 hours to run my program. Main program execution here, it starts by cleaning the old log files, and then it loads the sample dataset, extract HOG features, and perform the both keyfold and LOCP evaluations. And then all logs and the confusion matrix are automatically saved in the output folder. Also, the total computation time is written to the log file. And then, so this is the confusion matrix. As we can see here, the the letter A here, only the correct predictions only 379 because uh, some of A letter is wrong and read as C or E here. Then here B is good enough. Also C. Here the D also good, but some read as O. And then here the G is frequently, I mean, yeah, frequently read as the C or Q. Q. And then also the I with 321 correct, which is it's pretty much uh, read as L because it's kind of similar when the handwriting with the handwriting. And then also the L here, it's similar to I. And then N here, there there's some is read as M because it's kind of similar also. And here we got Z for the most accurate letter that read by the program. And then here is the ovulation log text for the fast tuning for this fast tuning. The matrix accuracy is 82.08%, and for the final evaluation here with LOCP, it's 82.82%, which is almost accurate, almost the same with the fast tuning checking. And then it takes 9.75 hours to run this program. Also, I put here the terminal outputs. It takes a long time to run this program. Okay, maybe that's all for my presentation today. Uh, Thank you for listening and have a good day.